You know, we spend literally billions of dollars trying to teach AI how to learn, but what if the real secret to making AI safe isn't about learning at all, but about forgetting? Today we're going to dig into a really fascinating paper that suggests targeted amnesia could be the key to fixing some of AI's worst habits. Let's get right into it.
So this is really the central question, isn't it? What happens when an AI learns something it shouldn't have? I mean, these large language models, they're unbelievably powerful. But that power definitely comes with a dark side.
And here's the thing, their power and their biggest weakness comes from the same place, the internet. They're trained on this gigantic, sprawling library of pretty much all human knowledge. I'm talking everything from Shakespeare to the wildest conspiracy theories, from groundbreaking science to entire copyrighted novels. It is, to put it mildly, a very messy, totally unfiltered mirror of us.
Okay, so problem number one is harmful content. It's pretty straightforward, right? If you train a model on toxic text from the internet, well, it's going to learn how to generate some really dangerous, biased, or just plain unethical stuff.
Then there's the whole issue of copyright leaks. These models can literally just memorize and spit out huge chunks of copyrighted books. And as you can imagine, that has led to some pretty massive lawsuits against the big AI companies.
And of course, the one we all know and, well, maybe don't love, hallucinations. The model picks up something that's just plain wrong from somewhere on the web, and then it states it with total confidence, like it's a fact. This isn't just misleading, it can be seriously dangerous, and it absolutely destroys user trust. So that brings us to the high cost of good behavior, right? We see the problems, but how do you actually fix them? Well, for a long time, the only real solution we had was, frankly, incredibly expensive and took forever. The go-to method is something called reinforcement learning from human feedback, or RLLF. You've probably heard of it. This is really the industry standard for what we call AI alignment, which is just a fancy term for the whole complicated process of trying to make sure these super powerful AIs actually act in ways that are helpful, harmless, and, don't go off the rails.
And this is where you can see the difference pretty starkly. RLHF is just so slow and expensive because you need a huge data set of good answers, and a lot of the time, humans have to sit there and write them. The unlearning approach that this paper introduces, it just flips that entire idea on its head. It's way more efficient because all you need are examples of what the model should not do.
Which leads us to the central idea here, the power of forgetting. I mean, instead of cramming more and more knowledge into these models, what if we could just surgically remove the bad stuff?
And this quote from the paper really just says it all, doesn't it? If practitioners only have limited resources, the first priority should be stopping LLMs from generating undesirable outputs rather than trying to make them generate desirable outputs. Basically, it's more important to stop the AI from messing up than it is to teach it to be perfect. Because it only takes one really bad answer to completely destroy a user's trust.
So the goal is super simple, visually. You start with a misaligned model, let's call it the red bot, the one that causes problems, and you use this unlearning technique to transform it into a safe, aligned model, the green bot, red to green. Simple as that.
All right, so how unlearning works? This is the big question, right? How does an AI actually forget something? Let's get into the mechanics of it.
Okay, the core technique here is called gradient ascent. The easiest way to think about it is like this. Normal learning, which is called gradient descent, is like a ball rolling down a hill, trying to find the lowest point. That's the right answer. Well, gradient ascent is the exact opposite. It's like kicking that ball uphill, forcing it to move away from a spot you don't want it to be in, which is the wrong answer. You're literally reversing the learning process for one specific piece of data.
And it breaks down into a pretty simple three-step process. Step 1, you find a bad output, like a harmful response. Step 2, you calculate what's called the gradient, which is basically just the mathematical direction that leads to that bad answer. And then step 3, and this is the clever part, you apply the opposite gradient. You give the model a little nudge in the completely opposite direction, which makes it way less likely to go down that same wrong path again.
So, unlearning in action. It all sounds great in theory, but the big question is, does it actually work? Well, this is where things get really interesting. Let's look at the results.
Let's start with harmful content. The original model was spitting out harmful responses about half the time, a 50% rate. That's not great. But after applying this unlearning technique, look at that. The rate just plummeted to less than 5%. That is a massive improvement.
Okay, but the results for copyright were maybe even more stunning. The original model was leaking protected text something like 80% of the time. 80%.
After they applied unlearning, that rate dropped to basically 0. It's like the AI's memory of that copyrighted material was just gone, wiped clean.
Now, anyone in this field will tell you that hallucinations are a notoriously tough nut to crack. But even here, unlearning made a huge dent. It cut the model's factual error rate from around 55% all the way down to 10%. Just think about that. You can literally teach a model to unlearn misinformation.
But honestly, this single number is the real bombshell of the whole paper. 2%. The unlearning method got these incredible results using only 2% of the computational time and resources of the standard RLHF pipeline. This isn't just a small improvement, you guys. This is a potential revolution in how we think about the efficiency of AI alignment.
So, this all points to a faster path to safety. What's the big takeaway here? It's that unlearning could offer a much faster, much cheaper, and way more accessible way to make AI systems safe for everybody. So let's just recap why this matters so much. First, it's way cheaper. You don't need expensive, human-written, good answers. You just need examples of bad behavior, which are easy to find. It's so much faster, using just a tiny fraction of the computing power of RLHF. It's clearly super effective. We saw the numbers on harmfulness, copyright, and hallucinations. And maybe most importantly, it's targeted. It lets developers do these little surgical strikes to fix specific problems, instead of having to retrain the entire model from scratch, which is a huge deal. And the researchers themselves put it perfectly in their conclusion. Our results show that unlearning is a promising approach of aligning LLMs, especially when practitioners do not have enough resources to apply other alignment techniques such as RLHF. And this is huge. For a long time, proper AI alignment was a game only the tech giants with unlimited budgets could play. A technique like this helps democratize AI safety. It gives smaller companies and even individual researchers the tools they need to build safer, more trustworthy AI.
So it leaves us with this final, kind of profound question. For decades, the entire race in AI has been about one thing: learning more and learning faster. But maybe this research forces us to ask something new. To build AI that is truly safe and robust, could the ability to forget be just as important as the ability to learn?
This is for entertainment purposes only.